Hi all, I'm back again. I have cell M. I was looking at it this morning and I thought a longer charge may work better. So I gave it a 2-minute charge on its standard 5 volts and its voltage went up to 2 and held there for a while, and it was also able to power the 1.5 LED light. So I'm going to demonstrate that. Cell M was the coffee grind cell, and its voltage was 0.95. We're just dropping down now, and it's been 4.5 hours since I charged it up and then ran it down with the LED. So I'll give it 2 minutes charge at 5 volts. Uh-oh, something's wrong. Oh. Yeah, connected the wrong lead. Alright, try it again. So 2 minutes charge at 5 volts. 5.3. I'll set the timer. And I'll get back just before it's charged. Okay, we're coming up to a 2-minute charge and 2 minutes, and we'll watch this. This should sit around about 2.4 volts and hold. So a little bit extra charge time, and it seems to work, unless it was, these were left in overnight in these solutions. We'll reset the timer. So the voltage drop is way less than it was the other day, and connecting a LED. I performed a bit better this morning when I did it, but it's still showing a point. Voltage isn't dropping so fast now, and without a load we'll see if it bounces back. And it's bounced back not too bad. So a little extra longer charge, and seems to make all the difference. The voltage is definitely holding longer. I think it was dropping rapidly yesterday. And again with the LED. yeah, I thought I'd just show you that. Yeah, it was quite interesting. And for a short circuit on it, what it's got left. That went up a bit. I didn't quite catch it. Yeah, alright, I might try another cell. Thanks for watching. Thought I'd check out cell B. Don't worry about the label, I just put it in the tub. Cell B was the mystery carbon. It had low results on all of the tests we had, so I thought I'd give that one a 2-minute charge, and we're at 2 minutes now. And we'll see where that sits today after a 2-minute charge. Yesterday, or the other tests, cell B was charged up to 2.6 and dropped rapidly, and its starting voltage was 0.8. And voltage seems to be slowing down. Well, as I said that, it's sped up. We'll see what happens when we connect the LED to this one. It's dropping faster than cell M did. So cell B is still probably performing less than cell M. And another cell I wanted to look at was the iron oxide cell P. I'm going to try giving that one, I might give P and Q a 2-minute charge. Still holding, it's got its light blaring away. But it's definitely dropping more than cell M did. Cell M, I think, oh, did we just go up? Either way, I think we're dropping. Or is it going to stay at 1.7? I was hoping it would drop down to past 1.5 so the light would go out. It's only taking 0.8 milliamps. Probably still not too bad for its size. And the recovery, it looks like it's going to hold at 1.66. No, it's dropped. And its recovery, still not that great as M. But still, better than it was the other day on a minute's charge. Seems to be responding, but they might get better after the more charges you do, so it's really hard to say and hard to test different types of carbons because the cell's construction may be different slightly. The thicknesses on the carbons were random. I was just tipping the liquid on and letting it set naturally. Some of the carbons flowed better, some were more absorbent of the polymer. so it didn't flow as much, so it was thicker coated. Right, I'm going to go try cell P and Q. I'll be back. Okay, we've hit 2 minutes on cell P's charge. And we'll see if this dissipates quickly. Oh yeah, this one's dropping rapid. Yep, won't even have enough for the LED. Oh yeah, how's that working? Oh yeah, we're still up high. Oh yeah, it's not too bad. I was thinking it was 1.2. That actually looks brighter on the camera. Could be the angle. Well, it's got a higher milliamp count, or it did have. Actually, it's, oh, I thought it was stable at 1.7. So I'm still a bit unsure of what carbon I should choose. Probably any carbon wouldn't really matter. One's what's most available to me, which is probably the most abundant one would be potato skin. It's running out, I think. And I'll do cell Q. We'll see what cell Q's like. Okay, coming up to 2 minutes charge on cell Q. That's 2 minutes. Cell Q had an accident. I broke the electrode right in half, but the carbon coating was holding it together, so I stuck another piece of this stuff behind the cell to stiffen it. So, not sure what we're going to get here. But the charge is disconnected, and we're holding 2.8 volts, so it sort of broke off about at that level from the electrode position. So it could be only this bit which is active. So the voltage is still up and it's slow. It's not as fast as it was dropping yesterday, because what we have the other day on the tests on cell Q, oh yeah, we did mark that was 10 seconds, but it's been longer than 10 seconds and it's 2.6 then. And it will run this little LED, I take it, at 2.55 volts or 4. Yeah, not too bad. That looks quite strong. We're getting some glow on the camera. And 8 milliamps. Wonder how you go about finding the optimum charge time for a cell. Well, actually they seem to run the LED not too bad. Most of those cells are picked at random. Even the busted cell. Don't know what part of the collector's doing all the work. That one seems to be holding, even though it's broken. Cell P was the graphite carbon nitride plus the derived resin carbon. Hopefully that one doesn't work very well, because that's really hard to come by and dirty. Well, the voltage is up still, and we've been running for a while. Little light's still running. I'm waiting for my computer to be freed up. I'm making a test video. It takes an hour to put in video format, so I was killing some time and wondering what I should do next with the cells. I think we've been running for about 3 minutes. Again, not too bad, little cell. No manganese dioxide in any of these, just the carbons on the sheet, coated electrodes. I think that one's performing not too bad, even though it's broken down the centre. It's missing half its cell. I have to try to keep my cells because I ran out of graphite. I won't be able to get some for a while. Most of the graphite got used up in trying to find the right mixture. Well, there you go. We'll check the voltage bounce back on this one. Its starting voltage was 0.81 on the other experiment, and we're at 1.8 and holding. They seem to be all holding their voltage now better, even with a little load. Oh, we'll do a short circuit maybe. 32 milliamps in that one. Well, look, we're not going to light. We've drained it. No, we'll see. Yep. Here we should be able to power on. Ah, no. Now. I didn't like that short circuit. Right on the limit. No lighting. Have I got something missing? Nope. Oh well, thanks for watching. I'll play around. If I find anything exciting in any of the cells, I'll report it. I couldn't resist it. Cell P and Q are now in parallel in the same solution, and that's a 2-minute charge. It seemed it'll be leaking. Oh yeah, it's going to hold at 2 volts nearly. Let's see a short circuit. No, it didn't have that much going for it. Oh yeah, it is just lit. Oh, there you go. Alright, thanks for watching. Enough playing around with cells. Hi again, I'm back. This time I have cell K and cell M. I have cell K's aluminium plate and cell M's carbon plate as a mixed match of carbons. Cell M is the coffee grinds and cell K is the potato skin carbon. And I discovered that they actually run the motor over here. This is an uncharged version at the moment, so it won't deliver. It's sort of only got 2.4 milliamps right on the volts. I'll give it a minute's charge, so it sort of matches the group of 3 tests we did with the other cells, and you should see when I hook it up to the motor the current draw of it. Alright, I'll get back when it's had 2 minutes. I'll just connect the charge first. Okay, so the charge voltage is around about 5, so we've got a bit to go up. We're taking 102 milliamps, dropping. Voltage did go up just then, I think. Yep. But I think the 1 minute, it's going to be over a minute now. Alright, so I started the counter now. So I'll get back. It's at 4.83 volts now. Okay, coming up to the charge with cell K and M combined. It's only 1 plate of each cell I'm using. Alright, that's a minute. And I'll connect the motor. It is spinning still, just. Spins for a while on one. Oh, I should have timed it. It's drawing 15 milliamps, 13 volts are dropping rapidly. And we got about 10 seconds out of it. Not too bad on a minute's charge. I'll give it 2 minutes charge. Okay, voltage bounced back okay, so 2 minutes charge starting now. I'll be back in 2 minutes. I'm back. I missed a count for 2 minutes. It's actually 4:45 seconds. We'll wait 5 minutes. And coming up to 5 minutes. Probably needs more because it should be set on 5 or at 4.8 and it's been going up to in value. Alright, 5 minutes. And I'll connect the motor. Delivering 60 milliamps just then. I think they're going to respond completely different if you mix and match the carbons now. And can't really tell the difference in the cells really. They vary. So I guess it comes down to what's available and easiest to produce and the cheapest. But I haven't tested the super carbons yet. The ones what are really heated up. That was a corn on the cob. Yeah, it was. Had no corn really left on it, it was just the cob. Right, the motor's stopped. And a rebound. So I didn't think they'd actually charged the motor. But they did. And we're going to bounce back up to nearly 2 volts probably. We could probably run the LED. Yeah, 2 volts on a 5-minute charge. It's only delivering 1.4 milliamps. It's glowing. Yeah, not too bad. And it bounces back up. That's alright actually. K and L K is potato skin, and M is coffee grinds. I have a much better coffee grind in the pot actually. A really conductive one. These carbons weren't very conductive. I think the only one that was conductive was the shop bought one, the activated carbon charcoal, and the rest were just baked at 700 degrees. And we're holding our voltage now pretty well. All the other cells in the last lot of tests at the in this video, sorry, with the longer charge actually held their voltage a lot better. We can hook that LED back up and it will glow again. So it's not too bad for these little cells. Alright, thanks for watching. Okay, this time I have K's carbon sheet on the negative side and M's carbon sheet on the positive side. And we'll give it a charge. I'll set the timer. We'll charge it for 1 minute. Setting charger, setting timer. Okay, alright, I'll be back in 1 minute. Coming up to a minute for the dual carbons, cell K and M. And that's 1 minute. Let's see what we have. I'm glad the voltage went up a bit because it was pretty low, but it looks like it's dropping. This will drop it. We'll see if this runs. Oh yeah. So that's a 2 carbon cell with different carbons on the electrodes. So it's like 3 different carbons. And our voltage recovery is higher than it started off at. It was 0.11, but not as good as the other one, the aluminium from cell K. Cell M's aluminium it was, and cell K's carbon. Yeah, so the double carbon bit down compared to the other 2 in the other test. But that was 1 minute. I'll try 2-minute charge. If it turns out to be anything, I'll come back and film it. This charger on for 5 minutes, but the voltage hasn't been going up. It's been going 6 and 7, 6 and 7. Now it's, oh yeah, there it goes again. It's been doing that. So we're at 5 minutes. And we'll see how long the little motor runs for this time. If I can connect it. 50 milliamps. So I think the other one was better, the other way around, aluminium and carbon from K&M. Notice there was hardly any bubbles coming off the dual carbons, not like the aluminium. I was setting the laptop timer. A bit late though. But we got 10 seconds of a count, so it's a bit more than 10. Probably 30 seconds, 40 seconds this run has been. I was going to say it's holding 0.2 volts. Well, there you go. Little cells, they're quite amazing sort of things. Not that these ones have too much power in them. But what they do have, they still amaze me. It's holding probably actually better than it was when it was in its own cells on a dead short. Alright, that's it. I think I might end playing around with the cells for today. Thanks for watching.